All right, let's get started with the exercises. So exercise 1, how many seconds are there in a century, assuming each year has 365 days? All right, so we're going to start off with a century, which has 100 years. And we're just going to assume for this exercise, they all have 365 days. We know that's not exactly true, but we will do as it says. So we need to find the number of seconds, which means we need to find the number of minutes, which means we need to find the number of hours in a day. So each of the 365 days has 24 hours. Each of those hours has 60 minutes, and each of those minutes has 60 seconds. So we just have to multiply all of those numbers together. Again, that's 100 years, has 365 days, has 24 hours, has 60 minutes, has 60 seconds, and we'll have this total number of seconds. So if we can count them, there is thousands, 600,000, 153 million. So 3,153,600,000 seconds in a century. Okay, let's move on to exercise 2. Write an expression to find the amount of money as a whole number rounded down to the nearest integer that each person would get if a $1 million lottery was divided equally amongst 436 people. So, all right, there's gonna be a $1 million lottery. Let's go ahead and write that down. So 1 million, 1, 2, 3, 1, 2, 3, so 6 zeros. And we're gonna divide it amongst 436 people. So the normal division sign, just one division, gives the exact amount per person. So including the parts of a dollar. We're not interested in the parts of a dollar. We want to round down to the nearest integer. So we're going to use floor division here. So Python has this nice floor division operator for us, and this will just truncate the decimals, just chop them off, and it'll bring it down to 2,293 per person. All right, repeat exercise 2, except use $1 trillion. It says to use the exponentiation operator instead of writing lots of zeros. So there are 12 zeros in a trillion. So we could just write all the zeros, but it's saying not to use that. Use the exponentiation operator. So if you remember, if you raise 10 to a power of something, there'll be that many zeros. So 10 raised to the power of 3, for instance, is a 1 followed by 3 zeros, or 1,000. If we do it to the 6th power, this is how you can get a million, a 1 followed by 6 zeros. So a trillion is 10 to the 12th power, like this, and we just want to repeat exercise 2, so we'll say floor division of 436, and we'll get this large number if a trillion was divided into 436 people. All right, let's move on to exercise 4. From the $1 million, how much more money is left over after giving each of the 436 people the amount of money calculated from exercise 2? So what's left over? So if we have this $1 million lottery, so there's this much money in the pot, how much is left over? Okay, we know that each person gets 2,293, but how much is left over? Well, this is simply using the modulus operator that we learned about. So modulus returns the remainder. That's the whole point of it. That's exactly what it does. So we take a million. We're going to divide it by 436. This returns the remainder. So what's left over after we've given this amount to everyone? And there is $252 left over. All right, let's go to exercise 5. Is 245 times 99 greater than 8 raised to the 5th power? So we want 245 times 99. Let's do this separately. So that's that number. I'm going to add a new cell, and then I can raise 8 to the 5th power and see which one is larger. Okay, so 8 to the 5th power is larger, but what I really want to do here is to do this in the same line. So I'm just going to delete this cell, and what I'm going to say is we can just test this using Python. So we'll just use this greater than operator. You don't have to write them in separate cells and then use your eyes to test. You can actually let Python do the comparison. So we have 245 times 99 is greater than 8 to the 5th power. Is it greater than? Well, no, it is false. So remember the order of operations. multiplication and exponentiation happen before the comparison operators. All right, let's do this. Number 6, use a chained comparison to show that 2 raised to the 10th power is greater than 10 raised to the 3rd power, which is greater than 31 squared. Okay, so there's 3 separate expressions here. So we have 2 raised to the 10th power is greater than 10 raised to the 3rd power is greater than 31 squared, like this. So this is the chained comparison. So we have 2 consecutive greater than signs. So 2 to the 10th, 10 to the 3rd, 31 squared. And is all of this true? All right, is this one larger than this one, larger than that one? And the answer is true. So we do confirm that. All right, number 7 is a little tricky. How many unary operators are present in the following expression? So unary means unary is an operator that has one argument. Okay, so we have to look here. Which ones have one argument? We learned the only unary, well, we did learn about 2 unary operators, the not operator and then the minus unary operator. So this technically right here, this is a unary operator over here. This negative sign for the 6 and also this negative sign for the 5. Now this is actually a minus operator because there's nothing else over here in front of the 4. So this is treated as a subtraction operation. Notice this is unary because we have this division sign right before it. That's what makes it unary. So we have, again, 1 right here, 2 right here. This is a subtraction that doesn't count. This is also subtraction, which doesn't count because there's nothing, again, right there. Raised to the power of 2, there's nothing there. Times a negative 1, so there is another one. So that means there's 3 unary operators over here. It's a little tricky to pull them apart, and you don't really think about unary operators like that, and it's not terribly important to know that, okay, this is a unary operator. You can just think of it as -6, and things should work out just fine. All right, number 8, create an expression that uses arithmetic, comparison, unary, and Boolean operators that evaluates to false. So we want to use all of our operators over here, and you can do whatever you want here. So let's just start off by getting rid of making sure we use a unary operator. So we can say -5 times, I don't know, say 10. Okay, so we have a unary operator and an arithmetic operator. A comparison operator will say, is this equal to 50? It's equal to -50, so that is false. We can run this right now and just test it. But we also need one of the Boolean operators. And we can say, we've already kind of used everything we needed to do. And we can say, and 20 is greater than 10. So we've used unary, arithmetic, comparison, and now a Boolean operator. So this is true, 20 is greater than 10, but this first part is false. So false and true will still evaluate as false, and that's what it asks us to do. So that's just one example. There are obviously an infinite number of more that can fit this. Exercise 9, you purchased a phone for $99. There is 8% sales tax. Compute the total price. Use 4 variable names to store the phone price, sales tax, percentage, calculated sales tax, and then the total price. Okay, so this is a practice of assignment statements. So we're going to say phone is assigned the value 99. The sales tax, and we'll say maybe percent. Say tax percent is 8%. So instead of writing just 8, well, we could write 8. We will, we'll just, tax percent, we'll say 8%. Then the calculated sales tax, so the actual tax, we'll just use the variable name tax. So we need to find the tax on this. So 99, and it's not just times 8, that would be a number close to 800, right? Percent, 8% is, we have to say divided by 100, right? So that's how we can make it into an actual decimal. So that would be 0.08. That's what is done. And so that is that's the actual tax. So we can look at this. Let's just look at this value. And you know what we can do right now is we can look at all of them. Phone, tax, percent, and then the actual tax. So we have the phone is 99, the tax percent is 8, and the actual tax that is paid in dollars is 792. And then we want the total price, so we'll just make another variable here. Should do it here. Total equals the phone plus the tax, right? So we're going to do 99 plus this tax that we calculated, and then we'll just add it over here so we can see all of them. It says output all the variables at the same time. So 99 for the phone, 8% tax, $7.92 for the tax, and then $106.92 for the total. All right, last one here. Exercise 10, use an augmented assignment statement to multiply x by y and reassign that value to y. So let's go ahead and execute this cell. We have x equals 16, y is assigned to 32. So augmented assignment statement, and we're going to do multiplication. So that tells you what symbol it is. So it's the times equal. We're going to do it like x. So we do 16 times 32 and then reassign it to y like this. And let's go ahead and print out y in a cell so we can see its value. All right, so that concludes the exercises, which is the project for Module 1.